In the last class, we study the database concept. Okay, what are the things, the basic things for the database. Now, today we are going to start with the run section. Okay, good morning. Now we are starting for the run section. I think there are 18 or 19 students they are joining. Anyway, we can start for the transaction. Okay, in this chapter, we are going to cover for the transaction concept, transaction state, concurrent execution, serializability, recoverability, implement of the isolation, transaction definition in SQL. Okay, then transaction concept. This is the transaction concept is the unit of program execute that access and possible update various data items. I mean that's usually the transaction is initiated by the user program written in a high level data manipulation language. Then we are using that language is the SQL, structural query language. We call for the SQL. Then we use, or otherwise you can write the programming language. Okay, now we are here. We are using the programming language in the C#. That also we can embed. Okay, with the embedded database access in OD, BC or other data provider. The A transaction is determined by the statement or function code. Then transaction inside you can write the statement. We call this each statement run by in the SQL statement or function. Sometimes you want a calculation or something, also then the inside the transaction you can include. There's a calculation, the function of the form begin transaction and end transaction. Then you can write the transaction is a end transaction, begin transaction and end transaction. Then if you execute the transaction, start isn't it? But we can make the many transactions, only not in the one transaction. Many transactions we can give the name also. Already we study for the transaction. That time we call for the commit and rollback. If you successfully everything is okay, then we can commit that transaction. Otherwise, if you roll back the transaction, that is the thing here we can use it. The transaction is the start, begin transaction and end transaction. The transaction consists of all operation execute between the begin transaction and end transaction. Because in the transaction, one transaction, it has the many tasks, not in the one task. Okay, many tasks you can include there in the transaction. This collection of the step must be appear to the user as a single individual unit. Okay, there's a one transaction like, but it has the many steps are there inside. But we call this the individual unit. Okay, for example, here the transaction to transfer the $5 from account A to account B. Okay, then transaction we had the one transaction is the answer the $50 from account A to account B. Then we want to inside the task want to check the balance, read the A, how much money is there. Then we had to do that, withdraw the money, $50, deduct the money. That's a. Then again want to change the balance. Already is a particular balance, and then after withdraw, another balance comes, the different the balance. Then read the B, how much is there in the B. Then after that we want to add the $50 is the deposit, the $50 in the B account. Then if you credit that $50 in the B, then we want to write the balance, the new balance, increase the $50. Already particular balance is there, but now increase the $50. This is the one transaction. But you can see there are 6 steps there. 6 steps. This is the transaction. We can call. There's a first one to read that balance. Okay. Already we discussed that is you are going to withdraw the money in the ATM card. Okay. They are checking. That's a little different. We are checking for the your card. Okay. Inside the card, password, validate. Your password is okay. Code. Then check the balance. Then you write. Okay. You type your how much you want to withdraw. It is check if enough balance is there or not. If you enough balance is there, they are proceed and reduce your money in the balance. That's the one of the transaction. But it has a many tasks inside the steps there. In here also, if you the example is a transaction, the transfer $50 from account A to account B. Then first want to read the A balance account. What is the balance is there? There has a amount. Balance mean amount. How much is there? Then deduct the $50. Okay, subtract that. Then write the new balance in the account A. Then read the B. Read the B. B account B balance. Then add the $50 in the B account the B. Okay, the $50 in the account B. Then write the balance. How much is now is the new balance account. The two main issues to deal with. Failure of the various kinds, such as a hardware failure and system crash. Then concurrent execution of the multiple transactions. Okay, these are the things sometimes failures happen. Then how to handle that transaction. That is the thing we are going to study. Now you can understand the simple transaction. It's the simple transaction is the we are going to transfer the $50 from one account to another account, for example. Then if you read A, which transfer the data item from A from the database to variable as called for the A, like we call that a read A means the variable A, the account. Okay. In buffer in main memory belong to the transaction that is execute the read operation. Okay, with the balance. So write is the mean which transfer the value in the variable A in the main memory buffer of the transaction. The execute the write to the data in the item A in the database. Okay, there's some update. We call this update because first we want to read the balance, then after deduct the $50 and write the balance, update the balance, right? Okay, read mean retrieve the data, right? Then you can understand that like. Okay, that's the possible things. Then transaction, we call this the one of the transaction. T1 is a transaction. Then you can put the separate transaction T1 and T2 also you can make the transaction. Let now you want to the transaction of the $50 from A account to B account. Then some times happen for the failure. It is the we call this a four concepts there: A, D, C, I, D. Okay, A, C, I, D. That's the thing we have to learn. Okay, already we discussed that things also, but again, want to discuss in here also. Okay, let us now consider each of the ACID property. For each of the presentation, we consider them in order to different from the order ACID. What is that? Now we can call for the atomicity requirement. Okay, if the transaction fail after the step 3. Okay, after the step 3 mean 4, 5, 6 are failed. For example, now is there A with the balance, again deduct the $50, withdraw the money like. Okay, that money want to deposit for the another account as a B in the B account. Then it happened this like up to 3 is okay, successfully complete. Successfully complete. But after that, okay, after the step 3 and before 6, money will be lost, leading to the an inconsistent database state. Failure could be software or some hardware failure. Okay, it happened that way. Then if happened that like, then we want to go to the previous state of the database. Mean again you deposit in the money into the account A, because the transaction won't complete. The withdrawal is successfully, but the deposit is not complete. Okay, the system should be ensure that update of the particular execution transaction are not reflected in the database. Okay, then in that atomicity is a requirement like, then it's to you can go to the previous state of the database. Mean again go to the previous old state. As A is the, for example, A is the $1,000 is there in the A account. Now you deduct the money in 50. Therefore, write the A is then $950. $950. But this is the failure for the this one. Before like it's a incomplete for the deposit in the B account. Okay, the failures happen, then go to the previous state of the transaction in the database. Then again, the update for the A is the now is the 1,000 because the failures happen. Okay, already we study in the database programming in the commit and rollback. If you successfully complete the transaction, you can commit. Otherwise, rollback and go to the previous state. Okay, last state. Previous means last state. That's it. Okay. Then we can see our books very clearly explain. Okay, suppose that just before the execution of the transaction T1, the value use of account A and B are $1,000 and $2,000 respectively. Now suppose that during the execution of the T1, okay, a failure occur, the prevent for the TI from completing its execution successfully. Further, suppose that the failure happened after the write A. Write A means after the step 3. Okay, operation, but before the write B operation. In this case, the value of the account A and B reflect the database are $950 and $2,000. The system destroy the $50 as the result of this failure. In particular things, we note that the sum A plus B is not longer preserved. No longer preserved. Thus, because of the failure, that state of the system no longer reflect a real state of the world that database is supposed to capture. We term such state in the inconsistent state. We must ensure that such inconsistencies are not visible in the database system. Note, however, that the system must be same point B2 an inconsistent state, even if the transaction D1 is executed, completes their existence point. Okay, which value of the A is $950 and the value of account B is 20, which is clearly the inconsistent state because incomplete that transaction. Okay, this state, however, is eventually replaced by the consistent state where the value of account A is $950 and the value of account B is $2,050. Thus, if the transaction never start and was guaranteed to complete, such an inconsistent state would be happen. Then the reason of the atomicity requirement, if the atomicity property is present, all action of the transaction are reflected in the database or no. The basic idea behind ensure atomic in is this: the database system keep the track of the all value. Okay, therefore the database keep it the all value, the previous all values there. But if the transaction is failure, it is go to the all value state. That's the atomicity. Okay, next is the durability. Is the one of the execution of the transaction complete successfully, and the user who initiate the transaction has been noticed that transfer of fund has taken place. It must be the case that no system failure can result in loss of the data corresponding of this transfer of fund. The durability property guarantee that once the transaction is complete successfully, all the update that is carried out on the database, then that's a durability. If the transaction is successfully, then if you guarantee all all data item is updated. Okay, that's a durability requirement is there. Okay, then transaction transfer $50 account to A to B account. Then consistent requirement. That's a then consistent. Consistent require here is that the sum of A and B be unchanged by the execution of the transaction. Okay, because we transfer the one fund, one account to another account, then the computer, the database, the total of the amount, both account, total of amount is unchanged. Unchanged means equal. First check A and B account, sum of that how much. Then after the transaction, how much A and B. That's the consistent requirements. Their consistency there. That also is the database do that. That's requirements also need. This is the one of the example fund transfer. Okay, this is happen for the other database also. For example, in the stock control. Okay, if you supply that is a stock is there, you keep it some goods. Then if you want to send that goods in the showroom, then you want to deduct the number of goods. Deduct the number of goods, the particular items. Then the storeroom update, there how many is get from the store. For example, if you send the 10 shops, 10 Lux soaps in the sales section, then the sales section update now is that earlier they have 20, now is the 10, is the 30. Then they want to update the 10. Is deduct 10 from stores and update at 10 from the sales. But the total stock is unchanged. That's the thing. That's a consistency. Okay, then you can understand now is that like okay, everything that's like you the balance the data balance the data means the amount. That's a consistent requirement. The above. Okay, generally the consistent requirement includes the explicitly specify integrity constraints such as a primary key and foreign keys. Implicitly integrate constraint a sum of the balance of all account minus sum of loan amount must equal value of the cash in hand. Okay, that's like you want to think about the balance. Okay, sometimes here mentioned about the explicitly specify the integrity of constraint such as the primary keys and foreign keys. Okay, the stock also, then I already the stock control. That's the primary keys there. What is the particular items going to transfer? Then you can use the primary keys, the Lux soap is the, but they have the many types of soap, but the Lux soap has one of the primary key. Okay, you can uniquely identify Lux. Okay, in here also the transaction mean that's the account A is the other unique account. But one person can make many accounts in the bank open. Okay, there's account number. It's a different. There's a unique. Okay, a transaction must be seen consistent database. The during transaction execute the database may be temporarily inconsistent. Okay, when the transactions complete successfully, the database must be consistent. Okay, erroneous transaction logically can be lead in the inconsistent state. Already for the inconsistent state. Okay, then we can keep it always the A plus B. The in here A plus B, that account amount is the consistent. That's a same. Okay, not change, unchanged balance. That. Okay, the example of the fund transfer is the isolate requirement. Okay, you want to isolate requirement. Okay, even the consistent of the consistent and atomic property are ensure for each transaction. Okay, then already mean atomicity and consistency. Then we are on to the consistency mean then successfully complete the transaction. Okay, that's the requirement is the issue. Like then atomicity is the transaction failure. It go to the previous state. Previous state mean the previous balance. Okay, therefore then the computer in the database keep it the temporarily keep it for the previous balance. If the transaction is successfully, then change that balance. But if your transaction is unsuccessful, go to the previous. That's a old balance. All mean previous state mean the immediate previous state. Not that. Okay, for example, as we show earlier, the database is temporarily inconsistent while the transaction to transfer fund from A to B is executed with the deduct of total return A and B increase total return in the B because we deduct the money from A to increase the money to B. Okay, if a second concurrently running the transaction, okay, read A and B at this intermediate point and compute A plus B, it will be observed an inconsistent value. Okay, inconsistent value, the balance is unchanged. Okay, balance is different. Okay, then furthermore, if the second transaction then perform update of A and B based on the inconsistent value, that is the okay that it read the database may be left in inconsistent state even after both transactions have completed. Okay. Then this thing in isolate can be ensure the trivial okay Okay, trivially by running the transaction seriously. Okay, serially. That is one after another. Other. Okay, one after another. That's the serious. Okay, continuously like this, serially. Okay, not parallel, the serially. Okay, then one after other. However, execute the multiple transaction concurrent has significant benefit and we see later. The concurrent we can put concurrent mean same time. Okay, if you make the two transactions in the particular same data item the same time, it is impossible. Then we won't give the concurrent control. At the specific time, only one transaction can allow for the particular data item. That's the isolation record. There's a concurrent control. Okay, we are going to study. The next chapter is the concurrent control. Okay, now he can see here is a acid properties. A transaction is the unit of program execute that access and possible update various data items to preserve the integrity of the data. The database system must be ensured. Integrity means is the accurate. Okay, correctly. Atomicity. Okay, either all operation of the transaction are properly reflected in the database or non. Transaction successful, all updated reflect in the data item, everything. Okay, then transaction unsuccessful, then reflect to the database update means go to the previous state. That's also update. In that example, successfully complete for the third steps, first, second, third step. But failure for the after three. But already we took the money, deduct the money, but other steps incomplete. Then go to the previous state. Consistent execution. Okay, execution of a transaction is isolated, preserve the condition of the database. Okay, inconsistent, you want to keep it there. Isolate. All the multiple transactions may be executed concurrently. Each transaction must be unaware of the other concurrent execution transaction. Okay. The intermediate transaction results must be hidden from other concurrent execution transaction. Okay. That is the for every pair of transaction T and Tj, it appears the Ti either Tj finish execution before T1 start. Okay, that's like serially want to do the transaction. Okay, if you did the money from A, then after want to someone if you put deposit the money in A, it happened. Then first to do that, deduct the money from A and that money deposit the B. But another person want to deposit the money into the account A. Then the transaction after. Okay, the durability after the transaction complete unsuccessful. The change it made the database proceed even if there are system failure. Sometimes the system failures go to the previous state. See, four properties in the database. Okay, therefore, Okay. Then we have on to come for the transaction state. Transaction state. Now you can understand that the four properties of the transaction want to complete the successful. We use this transaction state. Transaction state, but the state is there. As we noticed earlier, the transaction be completed execution successfully. Alone. Okay, always complete. Always complete. Execute successfully. Is the failures happen? Sometimes the failure is happen. Then the transaction is okay abroad. If we are into the atomicity parties and abroad the transactions no effect of the database. Okay, some failures happen. The atomicity is that there are no effect means that it is nothing is failure. Okay, failures happen. The keep it that A balance the previous balance. The B also already B nothing happened. Then B is the same. That's like is there. Then we had the state active. The initial state, the transaction stay in this state while it is executing. Okay, that's active that particular transaction. Partially committed after the final statement has been executed. Okay, but not in fully commit. Okay, some is only partially the some statement after the final statement has been executed. Fail after the discover. Okay, after discovery that normal execution can no longer proceed. Normal execution no longer proceed. Abroad, after the transaction has been rolled back and the database restore to its state, okay, prior to the start of the transaction to option after it had been abroad. The restart the transaction or kill the transaction. Again, the error is happened or failure something, then you can restart the same transaction. Okay. For example, the A and B is their transactions happen. Want to withdraw the money $5 from account A and deposit in the account B. But but we cannot read for that B account. Sometimes you give the wrong number. Okay, you give the wrong number for account number or something, then we couldn't read the B balance or sometimes some error. Then again you can restart that transaction again, give the error, correct the errors and give or kill the transaction. I mean you after successfully everything, then you can complete your transaction as a committed. Okay, already we study in the rollback and committed in the database programming. We write okay, do the commit and committed and rollback. Then we logical error is there, then you can commit because already successfully completed all tasks. If your errors happen, then you roll back, mean the go to the previous state. Okay, that time we add the two record in the customer table or an order table. Customer is there, then you can make the order. But the first want to add the order. Then it both want to successfully complete. That's a previous example in the database program. Now is the committed after successfully complete. Okay, there is a figure is there. This figure is the activate. Active means the particular transaction now is a running, execute. The partially committed. Okay, partially committed mean the inside some transaction is successfully complete, but fail for the sum in the other, okay, inside the task. Then you want to make that. So if you partially complete, then if you everything is okay, then you can committed. Partially complete mean it okay, run up to the final state. But okay, there are everything's okay, then you can commit the transaction. Then the changes happen in the update in the database. Changes update in the database. But other changes happen that update in the database. But in here, the partially committed, but the failure, some failures happen. Then you want to abort the transaction. Mean you want to kill the transaction. Okay, you want to leave the transaction. Okay, that's it. Simply we can explain this like. Okay, then a transaction start in the active state. When it finish its final statement, it okay enter the partial committed state. Okay, the up to go to the final state. This is the into the partial committed state. At this point, the transaction has completed its execution, but it is still possible. Okay, possible that it may have to be approved. Okay, some failures come or something in the failures sometimes. If you execute the last things, but last statement, but some failures, software failure, something happen. Then failures happen, then you can approve. Okay, that transaction you can approve. At this point, the transaction has complete its execution, but it's still possible that it may have to be approved since the actual output may still temporarily reside in main memory, and thus the hardware failure okay may okay produce the successfully complete. The database system then write out enough information to this that even a failure of the hardware, an update performed by the transaction can be recreated. Okay, again you can restart. Okay, in fact, the partially committed, but some failures happen, then you can restart that transaction and commit. Okay, when that last of this information is written out of the transaction, enter the commit state. A transaction enter the fail state after the system determine that the transaction can no longer proceed. Okay, with the normal execution because of some hardware. A transaction must be rolled back. Okay, you want to do the rollback mean go to the previous state. Then it enter the abort state. Okay, it go to the abort state mean we want to kill that transaction. You want to kill that transaction mean rollback. Okay, there are two option is there. If you abort the state, you can restart or kill. Okay, if you restart mean it's possible to run again. Okay, it can restart the transaction, but only if the transaction was brought as a result of some hardware or software that was not okay created through the internal logical of the transaction. A restart transaction is considered to be a new transaction. Okay, that was again restart. It can kill the transaction. It usually does so because of some initial internal logical error that can be corrected only by rewriting the application program, or because the input was bad, or because the data were not found in the database. Okay, sometimes I already mentioned, sometimes if you unable to read the balance in B. Okay, some they happen like then this is a failure. Then we can do that as a some error mean logical error like that. So you make the wrong number. Account number is wrong. Therefore, we cannot read that particular number is not there. Okay, what is the one? Chat is there. What is that? You cannot read the singular from to everyone. I cannot read. That's a okay. You write this English. Better everyone. There's a the look low. It's a low. Mima the what is I don't know. There's if you write the English, I can explain. One other may. Okay, some are writing. Okay, transaction process can. What is that? Can mean transaction process. Okay, transaction process mean any update happen in the database. We call the transaction. And be okay. You can ask the question. I not mute that mic. Okay. In between, if you have any doubt, you can ask. That's the transaction is there. Anything happen or update or delete, edit. Okay, edit mean update, forward and reserve together. So process can be forward and reverse together. Transaction process can be forward and reverse together, sir. Transaction mean is the transaction is the if you have the transaction is the one okay task any task happen in the database. You can insert that record, you can update record or delete record. It also happen. Okay, that means you can make many statement execute for the one transaction. But we want to check the transaction is successfully complete, then the changes is happen in the database. Okay, successfully complete in the reverse together mean if you the forward usually the answer everything if you write the program it read for the left to right. Okay, the read for the left to right and top to bottom. Okay, but top to bottom usually start for the beginning and end line. But it you think about that you have the 1,000 number of code is there. It is not bottom top to bottom line. But if you execute, it's a particular block. Want to execute that is happen in the order. Some serial continuous order. That's like. But the reverse together mean reverse mean if you one transaction happen, it can't do the reverse mean. If you successfully complete, it's a committed. You unwanted successfully, then you can roll back. That's a reverse. Okay, that's a reverse transaction. But if you, for example, you deposit the money for one account, okay, accidentally you make the different number. Okay, now the deposit machine is there. They ask for the all details. Detail mean your ID number. Okay, ID card number because who make that transaction. Okay, mistake to deposit the person. Okay, you want to put the if you for example A. Okay, withdraw the money to $50. Deposit the B account B, but and accidentally he make this small mistake to deposit the C. Okay, then this all are committed, successfully complete. Again, you realize, okay, I put the wrong person to deposit the money. Then your details are there. Then it is possible to change the account, but the transaction is completed. Another transaction you want to do, the withdraw the money to C, get from the permission to the particular bank. You cannot do particular bank office because I want to deposit that this money from me for the C, but I want to deposit in not C, B. Then you deduct the money and again make the transaction B. But there is a different transaction. But you can't go to the reverse mean, reverse together, forward and reverse together mean. That's not possible, but forward mean if you everything is okay. Okay. The reverse mean if you want to first want to your that transaction, the example is there, 6 steps is there, you want to go one by one steps. Okay, then reversely you cannot do it because if you deposit, withdraw the money, then you can deposit. Okay, then you want to deposit the money from in the B account, but where to get the money? If you have the money, then you can deposit. That's the thing. You can't do the reverse together. You can seriously, you can do it. Serious means continuous. Okay, continuous. That is the transaction. Okay, you can see there that here on the continuous transaction transfer $5 from account A to from account A to B transfer. Then want to deduct the money from first. After do that, right? Can't do the reverse way. Mean if you $50 already deposit. Okay, want to deposit this $50, then again want to give that like that also another transaction start for the B, deduct the $50 and like. But if you want to deposit the $50, we have to get that $50 from the A. Then we want to do the first this one. Okay, that's the if you unfailure for you this transaction, then you got the previous state mean if you withdraw the money from $50, then in unsuccessfully, then that A has the balance in the previous balance. Okay, all balance. For example, that in the book take the good example, $1,000 are there. Then if you read the first $1,000, then A deduct the want to withdraw the money, deduct the $50. Now is the right A mean the A balance is the $950. Then B has a $2,000. Then now at the 50, now is the $2,050. Then balance is the $250. There is a consistency there. Then we want to check it that the both sum of the A and B is unchanged. A and B is unchanged. That's a consistency requirement. Is there? Then we can't do that reverse way. Reverse way means here is the added money already added. Want to do that reverse. If you unsuccessfully, then reverse way is happen. Okay, because if you already you deposit the $50, okay, then B is there. But here unsuccessfully write the balance. You add the money, but want to update for the last thing. Already at the $50 at that, but unable to change that balance. Okay, some errors happen. Then it's the rollback. Roll back the transaction means roll back these steps. Then B is the 2000, A also deposit again, put it the A in the 50, the whole previous state is the $1,000. It is happy. Okay, this is the transaction state, active. Okay, the initial state, the transaction stay in this state while it is executing. That's active mean current active members. You are active student in our university. Okay, if you pass out, you are past students. That's like we want to make that a state. You are currently following our degree program. That's an active student. Now you are studying. That's is executing. That's the transaction is executing. The partially committed after the final statement has been executed. Okay, come for the final year. So for example, you are students. Now is that you are in the finals on students are final year. But unfortunately, you cannot complete for the project. Other exam are pass or something. Okay, that's a final state. Partially committed means the exam are passed. But sometimes exam are passed for the last semester, but it is incomplete for the previous semester or something like D or something that didn't like. Then it's a previous state. Then for we want to get, we cannot make for that student's decision not pass out. This not successfully complete the degree program. That's a fail. After the here is the partially committed. Okay, but if you check everything is okay for the students, everything the previous semester all exam are passed, he has enough average. Okay, EPA. That's like okay, he can pass. Otherwise, fail after discover the normal execution is can no longer proceed. Then fail for some purpose. Then you can abroad the transaction. That abroad transaction also two choices there. One is the restart or kill transaction. Then again restart the transaction, but they are mentioned for that's the new transaction. Okay, that's a new transaction because here we can make for the transaction T1, T2. Okay, for example, now is the you are making the payment. Okay, bill in the telecom, sorry, in your phone bill. Okay, your phone bill. Every month you want to pay the money. They keep it that also transaction. They keep it the transaction. Okay, for example, your amount this year, this month, phone bill, okay, amount is the 2000, but you pay only 1500. Then they make the transaction. Okay, you pay the 1500 and balance now is a 500 rupees for the this year, this month amount. Then this balance want to add for the next month because you didn't pay. Then that is the transaction. Everything we want to keep it the record. Okay, everything want to keep it the record. Otherwise, you think about now you okay. You can see in your bank book the transaction summary is there. If you deposit, withdrawal, when that everything you want to keep it. Otherwise, you can fight with them. I didn't withdraw the money for this day. Something you can fight. Okay, they didn't have the only they have any record for the transaction. They keep it the transaction in the file. Okay, already we study for the trigger function. If something happen in the database, we want to keep it the record. Okay, that's the transaction happen. Update the data or delete the record. Okay, that time I clearly explain for the if you cancel your registration, you are registered our university, want to cancel your registration, want to keep it the record. Otherwise, after 2 years, I never cancel my transaction degree program. Like you can come and fight to us. Then we want to produce that evidence. Then we can see that transaction. You this day you cancel your registration. Okay, then it's the transaction is that if you anything happen in the database, we want to do the transaction. We call that a transaction. Update, delete, insert. Okay, insert the row, update, or delete. That's also the transaction we call that. In here, in the bank example, is the update. because already the record is there. Already to account is there. But we want to update their balance. Update their balance means A is withdraw the $50 because A want to deposit in the B to $50. Therefore, the transaction happen. Then is the update. Read the balance for A. There's a read. Then want to deduct the money $50 and get the new balance A right there. Again, want to update the balance. Okay, because this transaction means the taxes happen if the database in the particular place. If you want to read the data, then you can do it. This tax, you can complete this tax. If you A having the money, then you cannot do that transaction in the step 2 is the like. Okay, A has a 0, balance is 0. Then it is possible to deduct the money? No. This is unsuccessfully. Okay, this is a unsuccessfully transaction, unsuccess transaction. Okay, then we study the 5 state. Okay, active state transaction, partially committed, fail, abroad, and committed. Okay, the committed means the successfully. Already we study the database programming is a committed. Then we use that is there is a error checking. Everything is complete successfully, both everything, then committed. Otherwise, go to the rollback. In the kill transaction in the rollback. The concurrent execution. The multiple transactions are allowed to run the concurrent in the system. Advantages are increase the process and disutilize. Okay, that concurrent control execution means at the same time want to run the many transactions. That's a concurrent, but in computer also allowed for that particular time. Only do that particular task. Okay, that's the answer. The increase of processors and this utilization lead to be better transaction through good. Okay, then one transaction can be using the CPU while another is reading from or writing to the disk. Okay, that also possible, but want to read the sometime want to the particular balance want to read but no write, but other transaction can write. That's also possible. That's a concurrent. Okay, reduce the average response time for the transaction. Short transaction need to not wait behind long one. Okay, sometimes some transaction happen in your database. Okay, for the balance or something, someone are putting like, but you want to get your balance only. There's a reading. That is possible. The short. Okay, not necessarily wait for the long one. Okay, the concurrent control scheme mechanism to achieve isolate. Okay, that is the to control the interaction among the concurrent transaction in order to prevent the from destroy. Okay, consistent of that database. Okay, therefore next chapter we are going to deeply we are going to study for the what is the concurrent control, concurrency control. It is the things. Then if the transaction is there, then you want to orderly do the transaction. Otherwise, is that you want to destroy in the consistent of the database. Okay. Then, for example, the balance account A. Okay, account A has the balance is $1,000. Okay, one transaction want to deduct for the $500. Okay, another transaction come for the $600 for the deduction. Okay, deduction, but it has the only $1,000, but want to withdraw the money, one transaction is 500, other one is a 600. But initially they read for the 1,000. But it is possible to withdraw? No, because one transaction is complete, 500 is deduct, then again start for the other transaction. Want to deduct for the 600. First check for the balance is in balance, insufficient balance. Then the answer, that second transaction is rolled back. Okay, that's a concurrent control. This is in order. The transaction is okay. Concurrent control in the order to prevent them from destroy the consistency of the database. We will study in this chapter, next chapter, after studying. Okay, notion of the concurrent. Okay, concurrentness of the concurrent execution. Okay, then concurrent control, we have the many control. You can lock the database and do the transaction, or the release the data lock and do another one can do the transaction. That's like we make the concurrent control, concurrency control. Schedule. Okay, schedule. A sequence of instruction that specify the chronological order in which instruction of the concurrent transaction are executed. Okay, then if you want to do the concurrent control, like which transaction want to execute first and do next, that's why we can schedule our transaction. A schedule for the set of transaction must consist of all instruction of these transactions. Okay, then it also consider for the that four properties. ACID property, ACID property must preserve the order in which the transactions appear in each individual transaction. Okay, then we call for the many transactions area, but we want to consider for the individually each transaction. A transaction that successfully complete its execution will have a commit instruction as the last statement. Okay, then we want to write the transaction when we want to write that commit statement at the last of the statement. Then that transaction is successfully complete. We make that a decision as the successfully complete. We default transaction assume to execute commit instruction as its last steps. Okay, then before the default transaction we make that is the line. Okay, if your errors happen, you roll back the transaction. That's the two things there. But if you successfully execute the whole thing, whole statement, then the last statement you want to make it is a commit this transaction. A transaction that failed to successfully complete its execute will have brought the instruction as the last statement as a rollback. Unsuccessfully complete, then we want to write that's a rollback. Brought the instruction as the last thing. Okay, this is the schedule. Transaction schedules are there, T1 and T2. Okay, two transaction is the serial schedule, mean continuous. Serial is you can see heard this serial, like you saw the drama. That's a serial drama. Some are short drama is only one day. If you show that drama in the particular time, after no, but it is a continuous. The serial schedule in which T1 has follow T2. Okay, this is the instruction is giving. Let T1 transfer $5 from A to B. Okay, T1 transfer $5 from A to B, and T2 transfer 10% of the balance from A to B. 10% of the balance. Now you hear this is the T1 as the first one to read that balance A. Then deduct the money, $50 from balance. Then write that new balance in the account A. Okay, for example, A has a $1,000. Now read the A, balance is $100, deduct the $50 as a now is the right A mean the new balance is the $950. Then, for example, B has a $2,000. The book mentions like that $2,000. Then read that B and add the $50 deposit. Okay, answer the deposit. Then B is now is the B right mean $2,050. $2,050 and commit. The first transfer T1 is successfully complete. Then we want to read A. Okay, A is now is how much? T2. The series. Then now is the A has a 950. The 10%. 95 want to deduct. 95 want to deduct. Then A is the now is a 95 deduct. Then new things come. Okay, write A. Read the balance. Okay, new balance. Then B. Put it that in the 10%. Okay, 10%. How much that? Right. Then now is the A is the read the 950. Then 10% is a $95. 10% is a $95. Then you want to deduct the 950 minus 95, 855. Okay, 855 was the balance A. Okay, but read the B. How much the B? B is the 2050. $2,050. Then again add that 95. Then 2,145. 2,145. Then commit B. This is the serially want to schedule. First want to do this one, then second it's at the same time. Okay, if you do the same time with this transaction, both at the same time, that's a concurrent in the same time, but we want to put the concurrent control because the serially schedule. First want to complete T1 and after T2. Okay, but the T1 is unsuccessful. T1 is unsuccessfully, then roll back. But now to T2 want the success. Then now is the read the A is the how much? 1,000. For example, T1 is unsuccessfully, but T2 is the success. Then T2 how much? Read the A 1,000. 10% 100. Then deduct the money 1,000 minus 100 900. Right, the A balance is 900. Previous is the 8,855. Is a because T1 is successfully committed, but T1 is unsuccess. Then T2 can do. Sometimes we want to wait for the T1 is unsuccess. We want to restart and complete. That's like, but this like, but here is a problem is the percentage is there. That percentage is there. What is the amount is there? We can deduct that percentage. Now is the right A balance is 900. Read B is a 2,000. Then B plus 10 is a 100, 2,100. Right, the balance is B is a 2,100. 2,100 commit. However, now it's a different balance because T1 is unsuccessful. But we have the schedule, the serially we can do that transaction T1 and T2. The schedule. Okay, there's a serial. Now is the here this is the schedule 2. A serial schedule T2 is followed by T1. T2 is followed by T1. T2 is followed by, there's a serial schedule there, but T2 is followed by T1. First want to do which one? Okay, first one is a T1 is followed by T2, that order. T1 is followed by T2. This is the serial is which is the T1 is followed by T2. There's a first one to complete T1, then followed to the T2 serials. But this is the schedule is there, is the different, but the transactions happen come for the same time sometime. That's right. But we can schedule T1. Now is a T2 is T2 is followed by T1. Then first want to commit the T2 transaction. Read the 1000, then how much 10% in 900 rupees for the A balance. Read the B is 2000. Then, but in here we can compare for the both. But if you compare the sum of the A and B is unchanged. Sum of A and B and unchanged. Okay, that's you can consider that like also. That's a inconsistent. Consistency is there. Then B is the B 2000 plus 100, 2100, and commit. Now is the A has the 900. Okay, 900 minus 50 is the 850. Okay, because the T1 is execute the first. Okay, but now is the balance is different. Both balance are different, but the altogether balance is sum of balance is unchanged. Now A is the 900, 900 minus 50, 850, right? A balance is right. B is the 2100 plus 50 is 2150. Write B and commit. Then this is the balance is different because the A is the 850, B is the 2150, but altogether is the 3000. But in this transaction, A is the 855 balance, B is the 2145. Okay, because there are different transactions happen in different schedule, different period. Okay, then it's the serial schedule in which transaction T1 is followed by T2. Okay, now schedule 3. Okay, let T1 and T2 be transaction defined. Okay, define previously. The following schedule is not a serial schedule. Okay, this is not a serial schedule, but it is equivalent to schedule 1. Okay, then here is the both transaction is the mix. Okay, in the schedule 1 and 2 and 3, sum of AB is a preserved. That's the unchanged, but the balance, individual balance is different for the transaction. Okay, but it is the equivalent to schedule first T1 transaction and T2 first read the A the same time. Okay, that is a read the A is a how much 1000. The T1. Okay, in the T1 you can see here T1. Read A minus 50, then write A is a 950. 950. Then read A. Now it's a 950 into 1%. Okay. If you write A mean after that reading here, this is a schedule mean time schedule. If you make here like this, both are reading the same thing. Okay, one after one. Okay. Then this also possible there's a get for the first schedule balance line. Okay. Now how much? A is the 950. Then 10% 95. then deduct the temp. Okay, 955, 855, 95, 955 minus 95, 855A. But here is the B. Okay, B is the 50. Already at the 50, that's like B is now is a 2050. Commit. Then again read the A balance is the 2050. Then B plus 10, 95, and B balance is B, how much? 2145 and commit. Okay, here is the A is the balance is the 855 is the 2145. Sum of B is the preserve, that's the same. But the okay, now it's a schedule 4. Okay, different. The following concurrent schedule does not preserve the value of A plus B. Okay, A plus B. Now you can see there is the read A minus 50, I. Now read A like A 10. Write A, how much is the like? Read the balance B. Read the balance B, 2000. Write A here. Okay. Write A again here. Balance how much? B. Then B plus 50, write B and commit. Then again B. Okay. Not okay, it's not okay. Does not preserve the value of A plus B. Okay. Then the schedule 4, what happened? Okay, then we want to can ensure the consistency of the database under the concurrent execution by the making sure that any schedule that is executed has the same effect as a schedule that would have occurred without any concurrent execution. That is, the schedule should be not okay. Some sense be equivalent to the serial schedule. Such schedule are called for serial liable schedule. Some serial schedule is there, but in the last one is the not in the serial schedule. This one is not in the serial schedule. Okay, then we can use for the these 3 schedules are okay. The serially continue. Okay, 2. These 2 are like, but this one also is equivalent to schedule 1. Okay, but not in the serial schedule. Is a mix-up. But this one is the T1 and schedule 1 and 2 is the serial schedule, but the different order. T1 and T is the serial schedule. We can call for the serializable schedule. It is such as a serializable schedule. Okay, now we can come for the things like basic assembly. Each transaction frees the database consistent. Okay, that's a consistent mean unchanged for their state. Okay, balance here in this transaction we are consider about the runs of the money, but both some of the runs okay, both some amount is the constant. There no change until. Okay, thus serial execution of the set of transaction preserve database consistency. A possible concurrent schedule is serializable if it is equivalent to a serial schedule. The different form of schedule equivalence give rise to the notation of the conflict serializability or view serializability. Then we can see that simplify the view of transaction. Okay, we ignore operation. Okay, other than read and write instruction. we assume that transaction may perform arbitrary, mean random. There's arbitrary mean there's a okay concept, okay concept computation on data in local buffer in between read and write. That's a arbitrary. Our okay simplified schedule consists of only read and write in instruction. Okay, we will give that say simply schedule consists of the read and write instructions are there. That's it. Now we can do the conflict instruction mean instruction I I and ij. There is a we are differentiate the two instructions. One is the I the state, other one the J is transaction. Okay, then we are related for the T I for the I instruction instruct to the transaction T I. Then ij instruction okay instruct to the transaction to tj respect. The conflict if only if there is exists sum of item q accessed by both. Okay, some same thing want to access the both one at the same time. That's a conflict. Both I and j and at least one of these instruction wrote q. Not Q. For example, here is I read the Q, IJ read the Q, and IJ doesn't conflict. Okay. I read the Q and write the Q, the conflict. Okay, at the same time. Same time read mean the same balance you can read, no problem. But the conflict mean if you I read that balance, okay, I in the queue. But IJ, the transaction, they give the right some queue, right? Then is the conflict at the same time. Okay, then I write the queue and read that also conflict. And same time on the write that balance also conflict. Okay, this is the logical thing instruction. Okay, both time if you read the balance, okay, no problem. But read and write or write read or write is the conflict. Okay. Okay, you can understand the conflict mean now read the balance, okay, both balance you can read at the same time. But if you do the changes, okay, read the balance mean that the changes happen already there, but the only read there what is the balance is there, read. But write mean is a make a change. You read that one, you make some changes at the same time is a conflict. Okay, if ij, okay, I and ii and ij are consecutive in a schedule and they do not conflict. Okay, their result would be remain the same even if they had been interchanged in the schedule. Okay, they are interchanged some schedule also. They are not. If not conflict, then they can interchange their schedule also. Okay, they are not conflict, then they can interchange their schedule. Okay, therefore here you can see they are in here. Okay, now the T1, T2. Here is the transaction there. First read the A and write the A and something like going up to commit. This is the one of the transaction. This is the 2, the schedule 1. Now in the schedule 1, the change for the schedule. There are no any conflict. There are no any conflict. Then they change the schedule. Interchange the schedule. Okay. Conflict serializability. If the schedule S can be transformed into the schedule S dash by a series of swap of non-conflict instruction. We okay, say that S and S dash are conflict equivalent. Okay, we say that schedule S is conflict serializable if it is conflict equivalent to serial schedule. Okay, we say that schedule S is conflict seriable if it is conflict equivalent to serial schedule. Okay, now you can conflict seriable. Read A, write A. T1. T2 also read A, write A. Here, read A, write A. Read B, write B. Okay, schedule 3 can be transferred into the schedule 6. Okay, a serial schedule where T2 follow T1, where T2 follow first T2 complete and follow the T1. Okay, by series of swap on non-conflict instruction. Therefore, schedule 3 is conflict serial. Okay, that schedule 3 is here, schedule 6 is there. Okay, now the schedule 3 can be transferred into the schedule 6. Okay, transfer the schedule 6. Now you can see here, read A, write A. Read B after, then next T2, read A, write A. Read B, write B. Okay, read B, write B. Then after that, start for the transaction T2 is the read B, write B. In schedule here, read A, write B, and read B, write B. Again, T2 is the series that read A, write A, read B, write B. Okay, again. But here is the sometime is the this amount inside. Sometimes you can include the other transaction, other steps also reduce or something and write. Then balance is here different. Then B also sometime inside something. Then here. But then here that is the T1 schedule can be transformed into the schedule 6, a serial schedule where T2 follow T1 by series of swap in non-conflict. Okay, there are no conflict instruction. Therefore, schedule 2 is conflict in seriability. Okay, the schedule 2, 3 is the conflict in seriability. Okay, it come here in the up. It is possible. Okay, the conflict seriability. Read Q. T3 is a read Q and write Q. Then write Q. We are okay. We are unable to swap instruction in the above schedule to obtain either serial schedule because T1 is the different schedule is there. Read and write. Here is a write only. T4. Okay. Example of the schedule is not conflict serial. Okay. Then T1, T2 and serial schedule T4 and T3. Okay, now I am going to stop. This is the boring line that you can read the book thoroughly. You can understand that what is the transaction. Okay, transaction mean is the some item is changed in the database or update or something. It is the transaction. Okay, if you one statement also there in the transaction, sometimes many statements also there. Okay, by this we can make the one transaction, one task or many tasks. It is possible to the transaction. You can see that transaction is the unit of program execute that access and possibility update the various data items. Okay, various data items. It is one data item or many item also you can change, update. But we consider for it is a one transaction, not in the many transactions. It's the one transaction. Okay, then this is here we make this is a transaction. T1 is the one transaction. Then T2 is the another transaction. T1 is the one transaction. T2 is the another transaction. In here we are making this schedule. T1 is the one transaction. T1 schedule transaction. This is the T2. Okay, this is the one is the deposit of money transfer the $50. This is the one transaction. Other transaction is the 10% want to transfer to A to B. This is another one. But altogether also you can make this the T1 and T2 is a one transaction like altogether make that like, but that is the serial, is order. Orderly you had to keep it that statement or steps. Okay, that's a serial continuous. Okay, again we can do the seriality transaction later. Okay, we have not in too much there, I think. Cover cascade rollback, concurrent control, weak level consistent, seriality transaction, right? Not in far. Okay, anyway, this is the little theoretical, but it is important for the database program. Okay, database program, some decision want to take. Okay, for example, in the bank also, you want to deposit the money. Then if you, during that deposition is time, the failures happen. Failure happen. Then you can get the previous balance. If you cannot get that previous balance, you can claim, okay, I keep it the 1 million in my account, like. Okay, 1 million is the previous date. I had the 1 million, but you like you can claim that because they haven't any evidence. But they in the database system, it is the keep it that's the previous all values. Okay, the transaction is successfully complete is the change for the old value to new value. Okay, that's the it happens the transaction. It has the 4 properties. Okay, then clearly you can read the book. Okay, you have enough time. Okay, you read that book. This is clearly explained. That is a good book. If you want, I will give another book also. But all books are same thing, explained, not different. Okay, then we come for that schedule, recoverable schedule next day. Cascadeless. Okay, cascadeless schedule. Like, okay. I think in the visual programming, only 1 lectures. After that, finished. Okay, then I will schedule that time also the database programming time. Okay, okay, only 1 lecture, so we can finish that Visual Basic. Then I can upload that some past, if you need the past paper and 1 or 2 past paper sample thing, you can see it. Okay, that LMS I can upload the past paper also. Now, okay, this is the transaction you can read and continue the next section and the next lectures also continue and start for the other concurrent control also. Okay, next class. Okay, you have any problem, you can discuss with me. Are you all are safe or informed? Okay, now you can talk any things. Okay, this is the mostly this is the theoretical things, but I will ask some question. Okay, for this the conflict transaction is right that like this you give that like then you can write. That's the thing. You want to understand this one is the transaction. But okay, already know there's something you want to get either data is a read and update the data is a write. That's the thing. But some calculation is there. That's also you want to do. Okay, so then I am going to stop. Any problem, any difficulty you can discuss with me. Okay, thank you for participate.